Welcome to The Explainer. We are jumping right into the fascinating mechanics of farming today. Now, you might think you know exactly how a farm works, but we're going to look at this through a grade 7 technology and livelihood education curriculum that literally strips agricultural technology down to its absolute bare-bones building blocks. It's actually a brilliant way to understand exactly how food production scales up, from a tiny little backyard plot all the way up to a massive commercial farm. Let's get into it.
But before we get into the heavy lifting, I've got to hook you with a quick mini quiz. Is a plow a tool or a piece of equipment? Go ahead, lock in your answer in your head. Got it? Okay, well, what if I told you that according to our source material, if you picked either tool or equipment, you'd actually be wrong? No way, right? But this specific question highlights a widespread point of confusion that trips up learners and adults alike. So stick with me. Because by the end of this explainer, you're going to know exactly why the plow doesn't fit into either of those boxes. To get there, we're following a super clear 3-part roadmap today. 1. Tools. 2. Implements. And 3. Equipment.
Section 1. The Great Farming Mix-Up.
Okay, let's dive right into this. Our source material highlights a really crucial distinction, stating, learners often confuse these with equipment, but the key distinction is that an implement is an attachment rather than a standalone motorized machine. You see, the reason this mix-up happens so often is, well, when we look out at a field, we just see a big machine doing work, right? We don't naturally separate the machine generating the power from the parts that are actually interacting with the dirt. But properly categorizing these components helps us fundamentally understand the true mechanics of farming. Honestly, it's the difference between just knowing how to drive a car and knowing how the engine actually turns the wheels.
Section 2. Tools, handheld and human-powered.
Let's start at our base level on the scale of power. Things powered entirely by human muscle. Agricultural tools are lightweight, handheld items. Because they rely totally on our own brawn, they're reserved for basic, smaller-scale tasks. We're talking about things like weeding a vegetable bed, digging little holes for seedlings, maybe pruning some branches. This right here is the absolute foundation of agriculture. Long before engines or even draft animals were put to work, literally everything was done with basic agricultural tools. Let's ground this in some super familiar examples: the bolo, the trowel, and the rake. Almost everyone knows what a trowel is, right? I mean, if you've ever kept a home garden, repotted a houseplant, or volunteered at a community farm, you've used an agricultural tool. They're accessible, they're simple, and they're entirely dependent on your own physical energy. But human power only scales so far. When it's time to prep an entire field for planting, well, we need to step it up.
Section 3. Implements, the heavy attachments.
Here is the fundamental definition that totally changes how we look at this. An agricultural implement is an accessory or attachment used for heavy land preparation that cannot operate on its own. I really want you to focus on those words for a second: accessory and attachment, because this right here is the category most heavily confused by students. An implement has no engine. It has no brain. If you leave it sitting in a field by itself, an implement does absolutely nothing.
Because an implement cannot work on its own, it strictly relies on external pulling power. Historically, and actually still very commonly today, this pulling power comes from draft animals, like a carabao, pulling through a muddy rice paddy. Alternatively, it comes from motorized machinery, like a tractor. The implement is simply the piece trailing behind, doing the dragging, the cutting, or the breaking up of the soil.
And that brings us right back to our opening mini-quiz. Common examples of implements include the harrow and, yep, you guessed it, the plow. So, would you call a plow a piece of equipment? Think again. The plow is the classic agricultural implement. It does the heavy lifting of turning the soil for sure, but it is utterly, completely useless without a carabao or a tractor to pull it.
Section 4. Equipment, the motorized muscle.
Now we're ready to introduce the final, most powerful category that takes farm work to a massive, highly efficient scale. What makes this category so unique is that it consists of heavy, standalone, motorized machinery. Unlike our human-powered tools, and completely unlike our dependent implements, agricultural equipment requires a mechanical power source, like an internal combustion engine, to operate. These are self-propelling machines.
Let's look at the heavy hitters here: tractors and threshers. And this brilliantly illustrates the leap in technological scale. You see, a tractor doesn't just do the work of one human with a trowel, or even one carabao pulling a plow. It does the work of dozens of them, significantly faster and way easier. This equipment is exactly what makes large-scale, modern commercial farming possible in the first place.
Now, what's really interesting about this comparison is how contrasting these two most confused categories side by side makes the distinction so incredibly obvious. You've got the implement, it's an accessory, an attachment, it desperately needs pulling power. Versus the equipment, it's standalone, it's motorized, and it provides its own mechanical power source. A super simple rule of thumb from our source text is this: the equipment provides the power needed to pull the implement.
Section 5. Working together on the farm. Of course, out in the real world, these categories don't just exist in isolation. Let's look at this dynamic duo in action. Step 1, the tractor, our piece of equipment, fires up and provides the immense engine power. Step 2, the plow, our implement, is securely attached to the back of that tractor. And Step 3, together, moving as one cohesive unit across the field, they perform the heavy land preparation. It's just a perfect marriage of a mechanical power source and a heavy-duty soil manipulation accessory. You literally cannot do large-scale plowing without both sides of this equation working together.
Synthesizing all of this makes the logic of farm mechanics incredibly clear, and it actually mirrors the exact classification exercises learners do in their curriculum. We scale up from tools powered by human muscle to implements pulled by an external force, all the way up to self-powered equipment driven by an engine, like a tractor. It is a perfect scale of power.
So why does all of this matter to us? Well, the big takeaway here is that categorizing these items correctly isn't just about passing some school quiz. It actually helps us deeply understand the evolution and scale of food production. When you know the real difference between human power, accessory mechanics, and engine power, you gain a brand new appreciation for the staggering amount of energy and technology required to bring food from the earth right to our dinner tables. It scales our understanding from a tiny backyard garden all the way up to massive global agriculture.
I'm going to leave you with this final thought. The next time you're driving down the highway and you look out and see a massive machine working out in a field, don't just look at it as one big block of metal. Ask yourself, using your brand new analytical perspective, which part is providing the power and which part is just the attachment? Which part is the equipment and which is the implement? Thank you so much for joining me on this explainer. Keep asking those great questions, and I'll see you next time.